guys, we have just covered the first two standards. The last one is natural selection. Survival is not random. Survivors must have an advantage over those that don't survive. A favorable trait gives the organisms an adaptive advantage. That's the third. And finally, the survivor's advantageous traits must be heritable. High fitness means an organism's ability to reproduce successfully. So I make my students memorize these four tenets. The one that they have kind of actually a hard time with and a misconception is with number one. They think it's different species have variation. But it's not across different species. The variations must be within the species for natural selection to occur. And here's Neil deGrasse Tyson, Cosmos. This is now, by the way, on Netflix as well. And this is his second episode. It's all about evolution. But this is a part that I show my students. I've cued it, and I gave you the cue there, 924. And he's going to talk about polar bears.
This might look like an ordinary bear, but something extraordinary is happening inside her. Something that will give rise to a new species. In order to see it, we'll need to descend down to a much smaller scale, to the cellular level, so that we can explore the bear's reproductive system. We'll take the subclavian artery through the heart. Almost there. Those are some of her eggs. To see what's going on in one of them, we'll have to get even smaller. We'll have to shrink down to the molecular level. Our ship of the imagination is now so small, you could fit 1 million of them into a grain of sand. See those guys over there strutting along those girders? They are proteins called kinesin. These kinesin are part of the transport crew that's busy moving cargo around the cell. How alien they seem. And yet, these tiny creatures, and beings like them, are a part of every living cell, including the ones inside you. If life has a sanctuary, it's here in the nucleus, which contains our DNA. The ancient scripture of our genetic code. And it's written in a language that all life can read. DNA is a molecule shaped like a long twisted ladder or double helix. The rungs of the ladder are made of 4 different kinds of smaller molecules. These are the letters of the genetic alphabet. Particular arrangements of those letters spell out the instructions for all living things, telling them how to grow, move, digest, sense the environment, heal, reproduce. The DNA double helix is a molecular machine with about 100 billion parts, called atoms. There are as many atoms in a single molecule of your DNA as there are stars in a typical galaxy. The same is true for dogs and bears and every living thing. We are, each of us, a little universe. The DNA message, handed down from cell to cell and from generation to generation, is copied with extreme care. The birth of a new DNA molecule begins when an unwinding protein separates the 2 strands of the double helix, breaking the rungs apart. Inside the liquid of the nucleus, the molecular letters of the genetic code float freely. Each strand of the helix copies its lost partner, resulting in 2 identical DNA molecules. That's how life reproduces genes and transmits them from one generation to the next. When a living cell divides in 2, each one takes away with it a complete copy of the DNA. A specialized protein proofreads to make sure that only the right letters are accepted so that the DNA is accurately copied. But nobody's perfect. Occasionally, a proofreading error slips through, making a small random change in the genetic instructions. A mutation has occurred in the bear's egg cell. A random event as tiny as this one can have consequences on a far grander scale. That mutation altered the gene that controls fur color. It will affect the production of dark pigment in the fur of the bear's offspring. Most mutations are harmless. Some are deadly. But a few, purely by chance, can give an organism a critical advantage over the competition. A year has passed. Our bear is now a mother. And as a result of that mutation, one of her 2 cubs was born with a white coat. When the cubs get old enough to venture out on their own, which bear is more likely to be able to sneak up on unsuspecting prey? The brown bear can be seen against the snow a mile away. The white bear prospers and passes on its own particular set of genes. This happens repeatedly. Over succeeding generations, the gene for white fur spreads through the entire population of Arctic bears. The gene for dark fur loses out in the competition for survival. Mutations are entirely random and happen all the time, but the environment rewards those that increase the chance for survival. It naturally selects the living things that are better suited to survive. And that selection is the opposite of random. The 2 populations of bears separated and over thousands of years evolved other characteristics that set them apart. They became different species. That's what Charles Darwin meant by the origin of species. An individual bear doesn't evolve. The population of bears evolves over generations. If the Arctic ice continues to dwindle due to global warming, the polar bears may go extinct. They'll be replaced by brown bears, better adapted to the now defrosted environment.
I think I did a lot of searching, and that is one of the clearest little snippets on those 4 things. And then you could go back and say there's variability within the population. There is a trait that increases chances of survival, fitness. That trait is heritable, and reproduction is not all survive to reproduce. All 4 are right there. He's very calm. The kids like the graphics. So that's a nice little snippet for you. He mentioned one of the misconceptions, and I have another little video there for you. The misconception he mentioned was number 2. The first misconception that kids have is that natural selection wants or tries to evolve, and that's not the case. Natural selection simply selects among whatever variations exist in a population, and the result is evolution. A note here, I hate that poster, t-shirt, graphic of the monkey evolving to human, because first of all, it's wrong. It gives people the wrong understanding of evolution. And so the misconceptions, one of the ones I address is that we never evolved from monkeys, and no scientist has ever said we've evolved from monkeys, and try to get that graphic out of your head. I think that graphic's done a lot more harm than good. The thing about wanting or trying to evolve, a great example of that are the cave fish in Mexico. They had eyes, and all of a sudden something changed in the environment, and the environment collapsed, whatever. They became cave fish. They're living in complete and total darkness. So now you have a fish that is born blind. He's no longer at a disadvantage. In an environment with light, that fish would never survive to reproduce. But in an environment in darkness, not only is he just as lucky, or he has just as many chances to reproduce as his fellow fish, he may actually even have a greater chance of reproducing because he's not expending energy on vision, which is a very expensive thing in a living organism. So over thousands of years, what happened was the fish, they have eye sockets, but they have no eyes. Now, all of a sudden, light returns to this environment. Too bad. Too bad, so sad. You're not going backwards. So like, oh my God, I need my vision again. they have no vision. So that's a little adaptation doesn't involve trying. That beaver can try and want a chainsaw as much as it can at once. It's not going to happen. The other one is the one that Dr. Neil deGrasse Tyson mentioned, is that people think that natural selection and evolution is random. It's a random process. That's absolutely false. So if you're beginning with that argument, you're beginning with the false argument. The crazy, I'm sure you've heard the idea that evolution states that it's a tornado going through a junkyard building a 747 and that just can't happen. You're right. That absolutely can't happen, and that's not what evolution is saying. Natural selection is sometimes interpreted as a random process. The genetic variation, the mutation, is random, but selection acts on that variation in a very non-random way. Genetic variants that aid survival and reproduction are much more likely to become common than variants that don't. So natural selection is not random. Next video, and I hope these are useful for you. This one's very kid-friendly and not very long.
Myths and misconceptions about evolution. Let's talk about evolution. You've probably heard that some people consider it controversial, even though most scientists don't. But even if you aren't one of those people, and you think you have a pretty good understanding of evolution, chances are you still believe some things about it that aren't entirely right. Things like, evolution is organisms adapting to their environment. This was an earlier, now discredited theory of evolution. Almost 60 years before Darwin published his book, Jean-Baptiste Lamarck proposed that creatures evolve by developing certain traits over their lifetimes, and then passing those on to their offspring. For example, he thought that because giraffes spent their lives stretching to reach leaves on higher branches, their children would be born with longer necks. But we know now that's not how genetic inheritance works. In fact, individual organisms don't evolve at all. Instead, random genetic mutations cause some giraffes to be born with longer necks, and that gives them a better chance to survive than the ones who weren't so lucky. Which brings us to survival of the fittest. This makes it sound like evolution always favors the biggest, strongest, or fastest creatures, which is not really the case. For one thing, evolutionary fitness is just a matter of how well suited they are to their current environment. If all the tall trees suddenly died out and only short grass was left, all those long-necked giraffes would be at a disadvantage. Secondly, survival is not how evolution occurs. Reproduction is. And the world is full of creatures like the male anglerfish, which is so small and ill-suited for survival at birth that it has to quickly find a mate before it dies. But at least we can say that if an organism dies without reproducing, it's evolutionarily useless, right? Wrong. Remember, natural selection happens not at the organism level, but at the genetic level. And the same gene that exists in one organism will also exist in its relatives. So a gene that makes an animal altruistically sacrifice itself to help the survival and future reproduction of its siblings or cousins can become more widespread than one that is solely concerned with self-preservation. Anything that lets more copies of the gene pass on to the next generation will serve its purpose. Except evolutionary purpose. One of the most difficult things to keep in mind about evolution is that when we say things like, genes want to make more copies of themselves, or even natural selection, we're actually using metaphors. A gene doesn't want anything, and there's no outside mechanism that selects which genes are best to preserve. All that happens is that random genetic mutations cause the organisms carrying them to behave or develop in different ways. Some of those ways result in more copies of the mutated gene being passed on, and so forth. Nor is there any predetermined plan progressing towards an ideal form. It's not ideal for the human eye to have a blind spot where the optic nerve exits the retina, but that's how it developed, starting from a simple photoreceptor cell. In retrospect, it would have been much more advantageous for humans to crave nutrients and vitamins rather than just calories. But over the millennia, during which our ancestors evolved, calories were scarce, and there was nothing to anticipate that this would later change so quickly. So, evolution proceeds blindly, step by step by step, creating all of the diversity we see in the natural world.